Hey, so welcome. My name is Zane Starr, and I am the founder of Ships and a co-founder of OpenRPC. And today I'm going to talk about how you can transform your JSON-RPC dev life with OpenRPC. So one of these things I wanted to start off with is how easy is it to talk about your JSON-RPC APIs? So JSON-RPC is kind of like you're going to call a method, and then it's got parameters. It's almost just like you're writing your own sort of code language, but it can be a little bit tricky to communicate this to your colleagues. So what really helps are docs. You're trying to talk JSON schema plus like stuff. So that could be like, oh, these are optional parameters. Oh, this has the shape of this, or like, how do we go about that? And so we really believe that being able to communicate your API through documentation is super useful. And so OpenRPC is looking to dive towards that aim. So really what we're all headed towards is the ability to discover APIs. So what it means is that when we're looking at JSON-RPC, we're trying to build a map for other people to dive through and really explore and know how to get to a certain place through your API. And so with OpenRPC, we're really building a map. So I'd like to introduce the OpenRPC ecosystem, which at a high level includes client generation, mock servers, server generation, interactive tooling, description language, API documents, and API discovery. So I've been kind of droning on, but I want to kind of level set and talk about what exactly is JSON-RPC. I want to go through like what is OpenRPC, what's the specification, and then talk about how you can actually transform your dev life using OpenRPC and the ecosystem tooling. And so we'll dive into things. So to start, JSON-RPC is just a really simple protocol. You essentially have methods, it's stateless. One of the sort of huge things about it is that it's transport agnostic. So what this means is that no matter what kind of system that you're talking about, you can use JSON-RPC over, say, IPC. You can use JSON-RPC over futuristic peer-to-peer protocols like libp2p. You can use JSON-RPC and UDP, HTTP, any sort of context that you have, you can use JSON-RPC, which is really a part of the power. And then it's remote procedure calls. Who doesn't like that? It's almost like you're writing code, but it's remote, it's happening somewhere else. And the spec itself is fairly simple. If you go to JSON-RPC.org, you'll see that the specification is only about 1 to 2 pages long, which is really like sort of nice to have something so terse. And then the other thing is there's wide usage. So if you look at blockchains today, almost every single one of them uses JSON-RPC, whether that's like Bitcoin, if it's Ethereum, if it's Near Protocol, and then even Microsoft uses JSON-RPC quite a bit for a lot of their services. So you have VS Code, you have Microsoft SQL Server that are using JSON-RPC. So what does JSON-RPC really look like? So a JSON-RPC request is this, more or less. So it consists of an identifier for your requests going out. It consists of the JSON-RPC version specification. So in this case, it's 2.0. There is a 1.0, but 2.0 is the latest. And then it consists of methods and params. And one way that you can sort of think about this is the same sort of way when we're talking about this, where you have these methods. And so in this case, it would be foobar. And then the value itself for your arguments would be like an integer and that kind of format. So essentially, we have the computer on the left. It's going to send a message to the computer on the right, and it's going to be in this sort of format. And then when the message is received, if they want to acknowledge and send back a response to that, you simply include the same ID that you had before, what version of the protocol you're speaking, and then you return back a result object. So the result object can be any sort of object that you want to specify. So this could be like a dictionary, it could be a string, and so within your specification you can say like, oh, what is this result thing that I'm returning back? And then the other thing to note is JSON-RPC also has its own sort of error object. So in the event of an error, you would just simply return back error, and then the body of that has an object, and inside of that there is a code to specify exactly what that error is. And so unlike traditional HTML or REST or HTTP sort of requests and RESTy things, there is no sort of 404, there's no 405, because that's very protocol specific. So you get these protocol agnostic error responses. So that's kind of how it's different from the way you would traditionally make a REST request. And then finally, JSON-RPC has a way for notifications. So a notification is simply any request that does not have an ID. So in this case, we're saying that we went from listing pets to creating a pet, and someone is telling you that they just created a pet. And so your job as the recipient of this notification, as a client or a server, because these things are interchangeable in JSON-RPC, there's not a strict client-server relationship, but it's easier to communicate and talk about when you're going from like a client-server perspective. So in this case, you've got a service that's telling another service something happened, and would you like to respond? But I don't actually care about your response. So that's why there's no ID. All right, so here's the thing with JSON-RPC. I was talking about how it's such a small spec, but JSON-RPC has this idea of RPC dot. And so what RPC dot is, it just means that you can essentially extend JSON-RPC any kind of way that you want. And the only requirement is that implementers of a JSON-RPC API do not have to implement this extension to be considered JSON-RPC. And so we're going to touch on this later about what OpenRPC does to JSON-RPC APIs to enable a lot of like magical connections. All right, so we've been moving at a clip, but I want to get into what is OpenRPC. So OpenRPC is a JSON document description language that is programming language agnostic that allows you to describe your JSON-RPC APIs. So it's human readable and machine readable. So there's a meta spec, which allows us to use machines to do generation and validation of documents, as well as clients and servers and all of these other kind of toolings. And one of the beautiful things about OpenRPC is that it's human readable. And so it allows us to look into a crystal ball and be able to capture these sort of things such as automation, testing for coverage, which we've done, client and server generation, docs, type generation in general. So let's say that you have a specification and you want to be able to talk about this object in front end of some sort. Well, we can generate types for that. So that way you can say like, oh, here are these kinds of objects that I'm dealing with that are coming over the wire, and have it all be nice and type safe and happy. So what is the spec? Here we are. All right, the spec at a glance looks like this. So the start of the spec is the OpenRPC version. So here we're saying the version is 1.2.1, and so every OpenRPC document starts like this. The next section that we have is info, which is kind of metadata about the spec. So we're saying that our JSON-RPC API for this demo pet store is at version 1.0.0. And it has this title, demo pet store. And then not shown here is a servers And this will allow you to do some automation around APIs and communicate to consumers of your API, like how they can access this service. So whether or not there's a production specific version or a staging specific version, you can also put this into your docs, very much so optionally. And then the next section is sort of the heart of everything, called methods. So methods are all the methods that your API implements. So we have this section called methods, and these things are called content descriptors. And what content descriptors enable are describing what is happening in this particular object. So what we have here is like the name of the method, the description, which is like, okay, this thing is going to do list all pets. Then we have the parameters, which are the arguments to our function. So in this case, the parameters are limit, and then the description for that is how many of these items we're going to return at once. And then we have our schema, which is actually able to be fully specified JSON schema. So right now, this is called like sort of inline JSON schema specification, but you can easily pop this out into its own JSON object. And this can also live across different protocols, because again, JSON-RPC is programming language and protocol agnostic. You can even specify that this exists on a distributed system, such as like IPFS. It could be your local file system. It could be your remote URI that you point to. And so it kind of allows us to have this kind of flexibility to resolve where these JSON schemas live at a point of convenience. So now that we've kind of talked about what's in a method, the other sort of part of this, because it's broken up into these sections, after you've specified the parameters for your method, you also want to specify what the result is. So here is going to be what the return type of our sort of JSON-RPC like method is. So here the return type is takes a name. So this is going to say like what is the name that we want to refer to. So when we're generating code, this will become more important, and it has like a nice name. So you get a return type for your object, and then you can refer to it. And then on top of that, it tells you like what is this thing that you're returning. So we're saying that we're going to return back an array of pets, and then it's going to have these items, which are the pet object with a name and a breed. Okay, so that was like the specification at a glance. It's really small. Our specification is only about 2 pages long, but there are a couple of sort of major things that we talked about in that overview. So we have the info section, which we were saying is about the metadata API, which was here. We have servers, which I talked about, but it's not shown here for space purposes and not required. Then we have methods, which are all the available methods on your API. And then we have this other section when it comes to extensibility called components. And what components allow you to do is to specify how you are describing your API in a way that's more portable. So if you have an object or a return type of your API that's used in multiple locations, in components, you would then break this out and specify what the schema is. So that way you can make a reference to it. So the next sort of side of this are the references. So we have the content descriptors, which I was talking to you about earlier, which are these. And then we have schemas, we have examples, we have links. So if you happen to attend any of the talks this week about link set, this is equivalent to link set. So what links allow you to do is they allow you to specify all of the associated methods with a method that you specified within the document. So let's say you had foo, and bar is going to tell you something more about foo. You can specify a link object to point to bar. So in your docs, you can then easily see like, oh, these are all of the associated methods with this particular endpoint. And so it becomes really useful, especially from a point of automation, to be able to say like, oh, these are how you use these things. And then there's the example pairing objects, which is able to sort of allow us to specify examples for people to use. And these also support JSON template language. And these are kind of more into the details. And then we have like tags and errors. So you can have various types of errors that return from your JSON-RPC API. An errors object just allows you to specify what that is. And the errors object looks very much so like the result, only it says errors. And it has like some properties around the code, etc. So what are the things we're doing around discoverability? So before, this spec here just talks about OpenRPC, the document description, but if you enable your service or server or your client to implement rpc.discover, which is this method, then it enables a whole host of different functionality that people can use for various things. So what rpc.discover is an extension to JSON-RPC that allows you to return back an OpenRPC document schema. And so this would mean that for our pet store implementation, rpc.discover would return back this particular spec. And so what this allows us to do is to basically point ourselves at an endpoint and get back documentation for that endpoint and then generate a client for it. You could even do this potentially in browser if you felt like doing it. And we've actually done this in practice a few years back, use OpenRPC, rpc.discover to do a reverse sort of envoy proxy. And so what that meant is we were able to say, hey, look, can you give me a service that looks like this? And then we're able to pull all of the available services that are running on that machine. And because we have the document description of what's implemented on them, we can then match that and launch that service for the user. So it gives you this ability to view your schema not just as a specific implementation of a narrow vertical, but to look outside of that and see things as more generic specs. So in the decentralized world and in the distributed systems world, for open services, there are oftentimes very lightweight specs of methods that you must implement to be considered this type of distributed client or this type of distributed service. So what OpenRPC allows you to do is to start building this sort of background of a library. And so we're starting to see some of these patterns emerge from some of the projects that are using it. Okay, so that was kind of a lot, but what I want to do is talk quickly about what the actual OpenRPC ecosystem looks like. So we have on the left this vertical called JSON Schema Tools. And so JSON Schema Tools includes all of the things that we do to power type generation, to do things like reference resolving. So before I was saying that within JSON Schema, you can have these things called refs, which are just like pointers to your JSON schema, and that these can live anywhere. So what we've done is we've architected a reference resolver that's extensible. Because JSON-RPC is transport agnostic, it means that you can then make requests to anywhere. And so in order to deal with that, and to allow people that are making specifications to deal with that, we've made a reference resolver interface that allows people to write their own customizations on this, and then plug this into the rest of our tool chain, so that way it just works. So you could write a reference resolver that then plugs into generator and then allows you to then generate code for documents that are hosted potentially on the blockchain or on your file system or over IPC or over any sort of protocol that you might have, or from one of your IoT devices that's using something like I2C. Who knows? The sky's the limit. Okay, so we talked a little bit about what's going on with the JSON schema tools, and on this side we have code generation. So we have a generator, which I'm going to demo, and so our generator is based on a plugin architecture, and so what this means is that you can then specify any sort of extension that you want to generate custom code for your JSON-RPC clients or custom documentation, and then we provide a framework for you to hook in. So the only thing you need to do is write a little bit of TypeScript and then implement an interface. And then you can go off and you can develop your own package, and then other people can npm install that, and then just run the client generator to generate clients. And so you don't actually have to directly integrate with our source code project. It can be completely orthogonal to anything you're doing. And then we have a couple of things that are used pretty widely. So we have client.js, which is just a simple TypeScript JSON-RPC client. And so basically it just means that it's really easy to extend this to use custom transports. I think 493 different projects are using client.js for their JSON-RPC request. And the reason why it's just for JS or TypeScript is because there wasn't a very good one at the time we wrote this. And so like us doing this was a good sort of community involvement. And other languages like Go, they have the RPC package. So we also have Go OpenRPC Reflect, which allows you to do decorators to generate OpenRPC documents directly from your code. This is used in production by one of the large sort of blockchain clients called Filecoin. And so that's really kind of interesting to see how that's working, as well as it's used by CoreGeth and a few other projects that have started to use this sort of pattern. And then on the interaction side, we have Inspector, which is like a GraphQL interface for your JSON-RPC. We have the Playground, which is like a place for you to play with your docs and to create them. We have React Docs, which is embeddable documentation. And then we have a mock server. And so we're going to do all the demos for that coming up. And then finally, on the right-hand side, we have formal specs for everything. So you'll see a JSON schema for our Open API or our OpenRPC documents. And so that allows us to do all of the validation and things and have nice hooks into VS Code so you can get auto complete and things like that going. All right, so I promised you a demo. We're going to go from idea to testing in 3 steps. And I'm just going to switch this over into demo land. All right, so here is our playground. I have it super zoomed in just so that way you can see it. On the left, we have our OpenRPC document. And this is just a sample document that we're putting together. Here we have the server section that I was talking about. You can do these things like templating. And then we have our methods. Here are the components I was talking about, and this has refs in it. So these are things that are defined outside of either the spec or are defined within the spec, just at another level. So you can have these all put together. So if you look here, you'll see that. And this is like kind of the basics of OpenRPC sort of, I don't have an IDE, I may just want to see what the spec looks like, and I might want to change some of the data and see how that's reflected. So if I call this simple math2, it shows up. On the left is a Monaco editor, so it has all your Vim bindings. You can change the color scheme of this, dark mode, light mode, all those kinds of bells and whistles, but that's not what I want to show off. What I want to show off is how easy it is to use the whole shebang of rpc.discover and just get something going. So one of the things that we created was this thing called a mock server. And so because we use rpc.discover, we can figure out how to interface and interact with a lot of projects that we have. So here, these docs are loaded directly from the service. We have a service called mock server that you can also run locally, but we have one running remotely on AWS that's hosted that anyone can use to spin up a mock service. So here, I went to mock.openrpc.org, and what I get back is this OpenRPC document. And now, on the left-hand side, I have all of the documentations for like how to use this service. So if I look, it says, oh, provides a mock server for OpenRPC document. Mock lasts about 15 minutes. All of this is just described within the spec. And then it says, okay, what are the formats or what are the things I need to get this going? Cool, and it tells me what I get back. So it gives me a path to append a URL to the mock server. So we're just gonna go and try this out now and see what happens. So when you hit try it now, it pops up this, and then we have mock. So what I'm gonna do is use some of the nice autocomplete features to take us there. So what I need, because we're using OpenRPC to generate OpenRPC, what I need is to go over and like find an OpenRPC document that I want to mock. So we were talking about pet store earlier. So I figured let's go ahead and grab a pet store example. So here I loaded up examples and I have pet store. Oh gosh. Don't die on me now. All right. I think we're good. Okay, so what we have is like this pet store example, which will allow us to just grab this document. So it's the pet store that we had in our spec. So I'm just going to copy this, and then I'm going to pop this into our specification. I'm going to hit play. This is a live demo. Okay, so when I hit play, the request went over the wire. This shows me like what the request was. And this is the way that the payload looked. And we see it was ID 0, so it's the first request that I made. And then if we look here, we show the responses to, I get a response from our mock service, and it says ID 0, and it gives us pet store 1.0. So here's one of the most miraculous things about this. So now we have this 1.0 mock service. And so what we want to do is go and test this thing out. And so it said that we could just append an address to the backside of this and then get something going. So I'm not sure if you saw that, but what it actually did is use rpc.discover to return back the spec for the mock service that we just spun up. So now, if we want to go and try any of these functions out, we can do something like, let's go ahead and choose list pets. It's a little bit harder to see because I'm so zoomed in, but let's zoom out a little bit and move forward. So if we go here, we can go and see we have this list pets function. So if we hit and try it now on the list pets, we scroll up, we can see that it auto-filled our request with the example. In this case, I'm going to change things from the example, so that way we get a different response. So here I've removed it, we hit list pets, and boom. What we've got is end-to-end testing just from the docs. There's been no code that's been written here except for the API specification. And so we can do this and it will generate fake results that match the pattern of our examples. So that way we can just hand this off to someone else and say, hey, look, I just spun up a mock server of the thing that I'm trying to work on, and now you can like develop against this. Well, you may say like, well, that's fine and dandy, but I don't want to have to curl these responses. So like, how do you go about building this in a way such that you don't have to go and curl this. And maybe this was a little bit clunky from a visual perspective. So what we also have is the lighter weight version of our tool called inspector. So as soon as this happens, this means that the document was loaded. And this allows us to know that, okay, this thing is servicing OpenRPC. It's got an endpoint that we can hit. And so now we can do things like figure out different stuff that we want to call. So we can do this. Let's go ahead and fill out a method and do JSON-RPC. And I'm just auto-completing my way through this. And then you'll see that it knows all of the different methods that were already there. We can call create pet. I have an error. Let's see. Oh, there it is. And I have another error. And call params. And maybe I'll use this, create pet example. And I can hit this. Boom. So there we go. We were just able to call a request. We see the request going out. We see the response. It tells us what this was. We can go back in time and see the history of different calls that have been made. And these are calls I made earlier in the day. So we can roll back and we see different things. If we want to replay this, in this case, this is a create with Bob and pet tag. We can do that. And boom. So one of the things I didn't mention is that JSON-RPC also allows for named parameters. And so this is just using the named parameters version. And it's just that simple to be able to have this drop-in tooling that just works. And so the next thing and sort of the last demo to go through is like talking about the generator. So oftentimes we're dealing in ecosystems and places where things are just slightly funky. Like, how do I go about sort of calling these plugins and dealing with all the sort of special cases of things? So we have a lot of ways to do that, and we've got a lot of examples around that. So I'm just going to roll through this really quickly. So what I have here is our client generator. So I'm going to go up to directories and call this. So typically the way that the client generator works is that you will call npm install at OpenRPC /generator, which is great. Then you would call OpenRPC generator init. And because it takes such a long time to sort of like npm install and all that stuff, I'm just going to keep on rolling. Select the client, select the language that I want to generate things in this case, select the docs name, and select package name. Cool. And so it generates a config file that you can then just run. All the commands are just all drop in. Boom. And just like that, because we wrote our own transpiler, we were able to transpile super fast. So some of the transpilation steps before were actually moving quite slow. So that's part of the reason why we did that. If you dig into it, you'll see more of the details. So now that we've got this client that's been generated, you probably want to have a look at what the code is. So if we go here and open up a client, you'll see TypeScript. We have a docs. So this is like fully generated Gatsby docs that you could just open or deploy to your service. You have source, and this is all of the sort of generated code. For the things that aren't named, you'll get mangled names, but for most things, out of the box, you'll get nice names. You can always title something, and when you title it, it'll just take on that name and the generated code. So here's our list pets. It's got nice types. You know exactly what it takes. So it's all very type-safe stuff. But what you want to see is like, how does this actually look? So here, what I've done is take that same pet store client. I npm installed it. This is going to point to our mock. We put it inside of a main, and then we can do things like await client dot get pet. That's it. And we'll put a pet ID. And const pet equals this. And we'll just do this on top of it. Right. And it allows us to just kind of know like what we're getting out of this. So in this case, when I call create pet, I know I'm going to get a number. When I call list pets, I know I'm going to get a promise of unordered string. Now we get a promise of list pets with nice types. So, and if I wanted to do something like set this to be let x string equals 9 D9 or something like that. And I said I wanted to set x equal to this. It's going to give me the error because, of course, the types aren't right. Okay, so I'm just going to undo that. And then I'm going to roll this up. And C, npx, tsc, double this down. All right, boom. So we read it. So here we called our list pets. We didn't get a pet, so that was null. And we got our value for the pet that we created. And so end to end, we were able to go from like basically no code. The only code we wrote was the code that would presumably be your front end code for testing out your mock. We were able to use the client that was generated from the spec that we had. We pulled in, we specified where this thing lived, which was our HTTPS mock OpenRPC with this path, the host, and the port. There's also parts of this where you can specify headers if you have that, or if it's a different custom transport, you can use that as well. And that's pretty much so it end to end. And then we have a lot of different hooks for doing things like plugins. So let's say that you were on a weird sort of system. So MetaMask, for instance, uses this for snaps, where you can then now specify how you want to communicate with your OpenRPC or your JSON-RPC. So if you had something that was very custom or special or niche, you can then specify a custom transport plugin. And this will allow you to then communicate using that plugin and the same tools. So you don't have to write any of this code to figure out how to make GraphQL-ish tooling work within your ecosystem. You can just simply co-opt it and write something outside the system and have that loaded up. And typically what you can do here is have this be as simple as a GitHub page that's hosted. Okay, and final couple of slides, where to next? Improve tooling integration. So part of this is like, how do we get people to use Inspector and Playground inside their own docs? And that is unstyled React components. So we're going through a major revamp of our UI, and we're really looking towards doing that. Better component sharing. So before I talked a little bit about API specs as entire type classes. So syntactic and semantic purposes. And then part of that is also thinking about how do you have components that are defined in different repositories and linked together. And then finally, more type generation. Earlier on, we had more languages that were supported. So we had Python, we had Golang, we had Rust, we had TypeScript, but we wanted to do some certain things better and more well. So we have TypeScript that's really well supported, Golang that's kind of well supported, and then Rust. So we were looking to just plus that support. So next steps. If you're interested, I encourage you to check out openrpc.org and follow us and go to the Discord, where we're pretty active. You can just drop a message and we're there. These slides are also on the speaker deck for Sketch, so just download them and check them out. And I think that's maybe close to time. So if there are any questions, that would be like, great, I'm here. Are there any questions? Go ahead.
Yeah, so just want to kind of observe that tool that you walk around, right? So everything was successful, we created paths, that's all. What happened to errors? Can you mock errors as well?
You can mock errors. I would say that it's probably a little bit more work in the sense that you have to add those errors to your specification and then figure out how you want to trigger them. I wouldn't say it's the most convenient thing to do.
But like, for example, your example is the create path, right?
Mhm.
Everything was basically smooth. But when you create something via a remote server, something can go wrong. So is there any way to trigger an error? Let's say next time I do something, well, that has to be set up specifically.
I think that would have to be set up specifically in the spec. So we don't really have a great way of doing RPC flows. So we experimented with this, which is like, how do you chronologically go through all of the different test cases for a system? And so part of that was just kind of figuring out what are the dependent states and things like that. And we kind of like spitballed on it, but didn't really dampen on like how that should happen. So the best way to trigger it is to actually set up your own flow of like what you want, and to do that more with the client side generation than within the spec. So yeah, that's a good question. But yeah, I can maybe show you, if you're interested in diving into like what we were spitballing around RPC flows. This was a little while ago when most of us were kind of here. But yeah, here's kind of an idea of an RPC flow meta schema. And so you can say like, oh, you have an RPC flow document, and you would say like, oh, this ties into this other like aspect. But I would just encourage you to just take a quick gander at like what we had going on here. Any other questions? All right. Well, thank you.